We are from Group 4 and in this video we will be presenting about the shaft we have designed. My name is Lim Yanjun and my matrix number is A159717. The shaft we have designed is a drive shaft of a car. These are the drive shaft in a drivetrain of a car. Drive shaft connects components of a drivetrain, transmitting torque and rotation from engine to them. These are the shafts we wanted to design in this report. A drive shaft is normally exposed to shear stress and torsion since it experiences driving force from its engine while also experiences resistance from its connected components. Thank you, that's all for the introductions.
Hello, my name is Muhammad Akashah bin Hamzah, matrix number A159106. So I would like to present the objective for our report for drive shaft design. So basically we already found three main objectives for our report, which is the first objective is to design a drive shaft that can be used in the car model so that the car model in the future will be more safe with our design. Secondly, to design a drive shaft that are safe to use. And lastly, to carry out the stress analysis of the drive shaft by using finite element analysis FEA program. Thank you.
The drive shaft material, we chosen a material through Cambridge Engineering Selector application. We have chosen the high carbon steel. We use the CES as our material selection program because it has the large database for material selection which can fulfill our criteria for our design product. As stock carriers, drive shafts are subject to torsion and shear stress, equivalent to the difference between the input torque and the load. They must therefore be strong enough to bear the stress while avoiding too much additional weight, as that would in turn increase the inertia. So it would be safe for consumer to use the drive shaft in the car without concerning about unwanted accident. So we choose high carbon steel.
My name is Peter Wang Qigong with normal metric A160659. Now I will present about the calculation of the driver shaft. In this project, we have assumed that the torque of the car is 500 M per M. And we have done three calculations in our project, which are shear stress, FEA, and safety factor. In result, we have divided the driver shaft into two sections, which the first section is 30 mm and the other section is 40 mm. In the section of 30 mm, we have calculated that the stresses are 9.45 MPa and the safety factor is 21.21. And for the section 2, which are 40 mm, the stresses is 3.98 MPa and the safety factor is 50.25. For the stress razor, we have two fillets which are 2.0 mm and another one is 1.05 mm. For 2.0 mm, the fillet, we have calculated the maximum stress is 14.33 MPa and the safety factor is 27.90. And for the fillet with 1.50 mm, the maximum stress is 15.39 MPa and the safety factor is 26.02. The affinity element analysis FEA, we also have calculated that the maximum displacement is 0.002385 mm and the safety factor is above 50. Thank you.
warahmatullahi wabarakatuh. My name is Nurul Safina and I will talk about discussion part. As for the project, our model was performed by using Autodesk Inventor 2018. The element retained in the Inventor have shown the constraint, moment at the both sides of the shaft, the displacement and also the safety factor. As we observe, the larger number of elements necessary to thickness or diameter of the shaft demands the high value of safety factor. From the result, we calculated the safety factor based on the diameter that have been set up and also calculated the maximum shear stress in the stress riser. The safety factor that we calculated has shown the value higher than 1, which means the stress in the model remains much inferior to the strength of the material, so that the safety factor is superior to 1 and model is safe.
Was to design a shaft which is safe for its intended use. In order to do that, we calculated the occurring stresses and the associated safety factors. We also did a finite element analysis from which we obtained the von Mises stress and the maximum displacement as well as another safety factor. For the calculations, we considered a torque of 500 Newton meters and a moment of 250 Newton meters. All in all, our designed drive shaft is very safe in terms of material failure for the considered torque because safety factors from both methods are much higher than 1. This means that the stress that occurs is significantly smaller than the strength of the material. Thank you for your attention and let us know if you have any questions about our project.